Hello, I'm Saurabh Goswami and I'm from Hyderabad. I'll be discussing a very relevant concept for the ITJ curriculum, that is how carbonyl compounds react with ionic species. Let's say this is a typical carbonyl compound. When it is trying to react with an ionic species, the ionic species can be taken in the form of a cation or could be taken in the form of an anion. The cationic species can very well be qualified as an electrophile, and the anionic species can very well be qualified as an nucleophile. Now, when a cationic or an anionic species is trying to interact with the carbonyl unit, what would make the two entities interact with each other? Is there any attractive interaction? Why I am saying this is because any reaction will always require some attractive interaction. Attractive interaction will always lead to reaction. Repulsive interactions never lead to reactions. Okay. For example, you would always want to chit chat with a friend who you are very fond of. That's an attractive interaction. That's a very favorable process. It will always reduce the potential in the system. You will feel relaxed. But you meet somebody who you do not like somebody to whom you have lent money, but he has not returned. So your interaction with that person will not be a favorable one, because it will result in some fights, some arguments, some debates, and that will increase the potential in the system, and that will be a repulsive interaction, not a favorable one. So you will not like it. Okay. So I need to look for a nature of attractive interaction which will be present between the two. Now, if I know a little bit of chemical bonding, I know for a fact that oxygen is more electronegative, carbon is less electronegative. So this bond is polarized. Oxygen has a partial negative charge, carbon has a partial positive charge. This is a dipole. These are ions. So can we identify what kind of interaction will be present? Yes. This is an ion dipole interaction. An ion dipole interaction is a fairly strong interaction, and that's the reason the force, and the reason why ion dipole interaction is a fairly strong interaction is because the force of ion dipole interaction varies as 1 by r square. So, what now? If this interaction takes place, an ion which is cationic will interact with the negative end of the dipole, and the anionic species will interact with the positive end of the dipole, which will result in something like this. Now, this is what it will look like. This is the ion dipole interaction resulting in a favorable interaction between the two species, or promoting the favorable interaction between the two species. What would this culminate into? What will be the end game of this interaction? The end game of this interaction is an addition reaction. How do we know? This is a pi bond. A pi bond would always want to convert into a sigma bond. The reason is a pi bond is a weak bond and a sigma bond is a stronger bond. A sigma bond is thermodynamically more stable than a pi bond, and so if the compound has any option, then it will always try to convert into a from a pi bonded state into a sigma bonded state. That's the reason, if you remember, alkenes tend to undergo addition reaction, but benzene was not trying to undergo addition reaction. Alkenes have pi bonds, benzene also has pi bonds, but benzene does not has this favorability towards addition reaction, because the pi bonds over there are involved in delocalization, which reduces aromaticity, or that's a very stabilizing factor. Molecule would not want to give up with that. Alkenes would want to convert into sigma bonded systems, alkanes or alkyl halides or alcohols, and the same argument holds over here. So the result is carbon interacting with the nucleophile, oxygen interacting with the electrophile. This is the addition reaction. Now, if both of these entities are derived from a reagent, for example, I take the example of HCN, hydrogen cyanide. If this breaks hydrolytically, it will give away H plus ion and Cl minus ion. I can take a number of other species where the compound can disintegrate to give cations and anions. And if cations and anions are both obtained and both are required for addition reaction, I now need to figure out that which interacts in the first step of the reaction, which interacts in the second step of the reaction, or both interactions do take place in the same step of the reaction. Now, it is highly unfavorable for a like 3 entities to interact simultaneously. That will be a highly crowded system and will be highly non-favorable. It's like 3 players trying to tackle a ball simultaneously on a football field. The chances that that will happen will be very less. Always 2 people will tackle pretty easily. So let's look at how many possible ways are there for this outcome to be achieved. There are 2 possible ways. So let's say we label this as possibility 1 and possibility 2. Possibility 1 involves cation interacting in the first step, followed by interaction of the anion. In second possibility, anion interacts in the first step at the designated site, and cation interacting in the second step. Now, we are going to discuss a very important concept which generally books ignore. In books, it's always written that carbonyl compounds undergo nucleophilic addition. जैसे एक blank statement दे दिया कि carbonyl compounds nucleophilic addition हो गया, उनको मान लेना है. What is the reason? This is something which students need to learn. This is something which GOC tells us. If we look from the basics, we'll always get these answers. Now, there are 2 steps involved in reaction. If the reaction is a non-elementary means takes place in more than one step. If a reaction is non-elementary, then the outcome of the reaction will be judged by the slowest step of the reaction. So I have to figure out that which is the slowest step of possibility 1, which is the slowest step of possibility 2. Outcome I know is addition, but whether nucleophile is interacting in the slowest step or electrophile is interacting in the slowest step, I don't know. Half of the students will think that cation since interacts in the first step of the reaction, so ye slow ho jayega, ye fast. Anion interacts in the first step, so this will be slow, this will be fast. So this will become electrophilic addition, this will become nucleophilic addition, which is incorrect. The correct way of identifying the outcome is to look at the change when addition reaction is occurring. So a B unit with relevant charges is interacting to form this. If we look at the hybridization of carbon, this is sp2, this is sp3. A molecule moves from a sp2 system to a sp3 system, thereby the molecule becomes more crowded. Becoming more crowded is not favored. Thermodynamically the reaction is favored because sigma bonds are formed, but sterically the reaction is not favored. So that whole outcome will be dependent on the slowest step of the reaction, or will be the rate of the whole outcome will be guided by the slowest step of the reaction, and the slowest step of the reaction will be one in which crowding is increasing. So what we need to do is we look at the hybridization of the carbon atom in all these species, and in that step in which hybridization changes immediately from a planar to a tetrahedral system, I'll qualify that as the slowest step of the reaction because that will not be favorable. So sp2, sp2, sp3. So this will become slow, this will become fast. sp3, sorry, sp2, sp3, sp3. This will be slow, this will be fast. If I closely look at the slow step of the reaction, both the possibilities, which entity is involved? The nucleophile. So the reaction will be qualified as a nucleophilic addition reaction because nucleophile is involved in the slowest step of the reaction. Okay. So this will be the outcome and will qualify no matter whether possibility 1 is achieved or possibility 2 is achieved, will qualify this reaction as a nucleophilic addition reaction. Thank you.